Welcome to the video on Chapter 3, Lesson 1, Angles. This video will actually also include Lesson 2 about angle measures. The only part we will be skipping will be the part where it references using a protractor to actually measure the angles. So by the end of this video, we should be able to answer how do we name angles and identify their parts. Let's start with some vocabulary. A straight angle is a figure formed by opposite rays. So there's the endpoint for the ray going to the right and then the ray also going to the left. This is a straight angle, which should make sense because it looks like a straight line. If we connect two rays but they are not collinear, means that they are not creating a line, then you actually form an angle. So it's the figure formed by two non-collinear rays with a common endpoint. So there's that endpoint, but now the rays are going in a separate direction that is not creating a line. Lastly, the vertex is the point where two or more lines, curves, or edges meet. It's that common endpoint. That's called the vertex. When we are naming angles, there are actually 4 ways to do that. The first 2 ways actually comes from this area right here. Okay, so the vertex is actually labeled B, so angle B would be one way that we could name the angle. And then that little 1 inside the angle is also a way that we name angles, so angle 1, and that number would be located inside the angle like you see there. The other way to do it, which is most common, actually uses the points that are identified along each ray. So for this example, we have A, B, C, so we can call it angle A, B, C, or just like with our lines, we can go in the opposite direction and call it C, B, A. The only thing that must happen is that B must be in the middle that references that angle. So angle A, B, C, and angle C, B, A. Again, making sure that the B is in the middle when you use that method for naming. Go ahead and pause the video and try this one on your own, naming the angle 4 different ways. Hopefully you came up with that angle G, that's the letter identified at the vertex, and angle 2, which is the number inside the angle, and then your 2 options for using the letters, those points there would be K, G, P, or P, G, K. Again, as long as the G is in the middle, referencing that vertex, that end point where the 2 rays are meeting. That's very important. In this example, we have 2 angles that share a ray, the ray RT in this case, and so when we're naming them, notice that it's angle QRT and angle 3 reference that angle in here, angle TRS and angle 4 reference this angle here off to the right, and then there is one whole angle, angle QRS. You do not want to call that larger angle QRS as just angle R, because angle R has actually 3 angles at that one vertex. It's got the one QRT, it has TRS, and then it also has QRS. So you are not allowed to call this particular angle just angle R because it doesn't identify which of the 3 you're actually referring to. So just keep notice of that whenever there are shared rays. An angle separates a plane or a space into 3 parts. And I did kind of already reference this when I was talking about that number, like when we were naming the angles using the number that was on the inside. This is the interior of the angle. It's in between the 2 rays inside there. The exterior is that outside area, and on the angle itself would be on one of the rays. So that's your 3 separate parts: interior, exterior, or on. So let's say that X is a point and we want to figure out an angle where X is on the interior, on the inside of the angle. Well, it's really only one angle, but 2 different names, angle YAR or angle RAY. That is the angle where X is on the inside. This is the exterior, which is where we will get to next with the angle Y, or the Y being on the exterior. So we're going to name an angle where Y is on the outside of it. In order for y to be on the outside, angle XAR or RAX, it's that same angle, just two different ways to name it. That's where y is on the outside, it's on the exterior of that angle. And again, we're not just using angle A to name these angles just for the answer, because there are too many angles at this vertex here, at this spot, at this endpoint where the rays are meeting. So you have to say angle XAR or RAX is where y is on the exterior. So go ahead and pause the video and try these on your own. You are finding a vertex, you're naming 3 angles, you're naming an angle with D as the exterior, and you're naming an angle with A and the interior. So pause the video, give that a try before you move on. Go ahead and take a second to check your answers, and just know that this really completes the lesson 1 for chapter 3, and now we're going to move on to technically lesson 2. So if you need to get out your other set of notes, please do so. So let's move on to some vocabulary where we are going to define the word degree. So a degree is the basic unit of measure for angles, and we write it with the number, not this actual symbol here. You replace it with the number with that little tiny superscripted floating circle up top. And we don't read it as superscripted circle, we read it as degree. So 1 degree is equal to 1/360th of a circle. So what that references is that in a circle there are 360 degrees. So there's 0 going the whole way around to 360. Okay, and there's a 0 down here too. Doesn't matter where you start, it's 360 degrees inside of a circle. So when we're talking about angles, we're referencing its unit of measure really compared to that circle. And though we are going to skip the part of this lesson where you will actually be using a protractor hands-on and drawing those angles or reading those angles with a protractor in your hands, it is still important to understand what a protractor is and how it works. So the protractor is what we use to measure the angles, because for every angle there is a unique positive number between 0 and 180 called the degree measure of the angle. So we will use the protractor. So you can see that either side there's a 0. It's just a matter of you picking where you're starting at. So if your one ray is here and you're starting at 0, then you're going to use the top numbers. But if your ray is in this direction and that's what you're lining up with, then you'd use the 0 in the bottom numbers. So that's how you have to know whether to use the top or bottom, and that is the biggest mistake that students make when they're using a protractor, is not paying attention to the top or bottom number that they should be using. They should be using the bottom and they end up using the top, or vice versa. So just make sure you're paying attention to where you're lining up that 0, where that ray is at the bottom. We do have names specifically for 3 types of angles. We have a right angle, an acute angle, and an obtuse angle. And most of this is review, which is why we're moving so quickly through it. A right angle is when your angle measures exactly 90 degrees, and that is normally indicated with a square, a little block down there in the angle. At the end point of that vertex there. So that's identifying the right angle of 90 degrees. So the measure of the angle is 90 degrees. If the measure of the angle is less than 90 degrees, then we call it acute. And then if it is greater than 90 but less than 180 degrees, we call it obtuse. So just keep in mind that we will always be measuring the angle that is less than 180 degrees. So all of your angles will fit into one of these 3 categories. It will either equal 90, be less than 90, or between 90 and 180 degrees. Most of the time we can classify right, acute, or obtuse simply by looking at the angles. So take a look at these and see if you can come up with a quick idea as to what you think the answer might be. And this is just classifying them, so right, acute, or obtuse. And we'll take a second before we move on to the next slide. So pause it, take a look at what you think it might be, right, acute, or obtuse. So I hope your answers are matched the ones that I have up there. And I guess the big thing I want to show right now is just to remember when we're measuring between the 0 and 180, for example, this measure of angle 2 here. I'm interested in this measure here. I'm not measuring this exterior angle. We're always going to be interested in that interior value. So even angle 3 is obtuse, it's still that interior value here. We're not looking for this number that's greater than 180 degrees. So just keep that in mind as we are naming and measuring angles.